Awesome. So, welcome to the last class of Python and Pygame. You all are the survivors. I don't know what happened to the rest of these folks. Today we're going to cover exceptions and libraries. So last class, we went over classes, objects, packages, modules. Do you guys have any questions after taking a peek at some code, poking around with things?
Class is a blueprint. An object is an instance of what is in the class.
Correct.
A package is just another file with some functions and data call.
Yes. Well, no. A module is a file with functions and data. A package is a folder with a underscore init underscore .py file in it that contains multiple modules or packages. Any other quick questions before we start talking about exceptions? Tim, are we good?
Yeah, I'm just.
All right.
Just trying to make sure.
Cool. Any other questions before I dive right into exceptions and libraries? Today there's going to be a bunch of sample code. So today we're going to cover exceptions. We're going to cover libraries, specifically a bunch of ones that are packaged with Python, and then one third-party library. For all you microcontroller folks, I'm going to talk about PySerial really quick, so you guys can figure out how to write serial data through Python, which is nice. There's a lot of sample code for this class. I'm going to pick 3 or 4 examples based on what you guys want to see, and then we're going to cover it. But first, we're going to talk about exceptions. So throughout the class, we've seen a few errors, mainly when I type something incorrectly into a Python shell. Errors detected during code execution are called exceptions in Python. Exceptions happen for a huge number of reasons. Those include syntax errors when things are tabbed and not spaced, or spaced and not tabbed. That's an exception. If you divide by 0, that's an exception. If you try and access something whose name does not yet exist in your program, that's an exception. So all of the errors you ever see in Python are exceptions. They're all named, so you can all see what they are and what's going wrong in your code. And there's fun ways to deal with them in a way that makes it so your code does not crash. Exceptions bubble up in your program. What I mean by bubble up is when you're writing a piece of code, generally you're calling multiple functions. So you kind of go deep. From your main function, you call a second function, which calls a third function, which calls a fourth function. If that fourth function errors and doesn't handle the error, it's going to bounce back to the third, bounce back to the second, bounce back to main, and then eventually it will bounce back up to Python itself, which will then crash your program. Right? Does that make sense? Is that weird? All right, so what I mean by bubbling up, right? So in your program, generally you're going to be within some deep nest of functions, right? So you have a main function, which calls a function, which calls a second function, which calls a third. And if the third errors, throws an exception, it's going to bounce back to the third, then the second, and then the first, and then main. And then if main doesn't handle it, it's going to bounce back to Python and then break your program. It's going to kill it on the spot.
But it could be handled.
Exactly. Yes, you can handle your exception wherever in that chain. So if you want to handle it in the second function for whatever reason, if that makes sense to you, do it that way. Doesn't really matter as long as you catch it.
And handling it would be, if in the second function, say, if the third function returns an error, do something else instead?
Exactly. So a concrete example would be file I/O, right? You're trying to read from a file. That file doesn't exist. It's going to throw an exception, right? And you have some read function that's just trying to read data. That's going to throw an error, and then the function that calls the read function is going to be oh, I can't read right now. Here's what I'm going to tell the user, right? That's the kind of thing you'll do, right? So exception handling. It's a new type of syntax that we haven't seen before. It's very similar to the rest of the stuff. It's done in blocks, like an if statement would be or a loop would be. Handling exceptions requires the use of try and except blocks. The try block contains code that will be executed that may or may not error. The except block specifies what error we expect and how to recover from said error. And then there's an optional else. You don't really need an else, but the else is always going to be run after the except, right? I think that's true. Yeah, I'm going to go with that. Prove me wrong if you can. Then let me know the results. So right here in this example, if we run it, just for the giggles, if we do a this bigger. Go ahead and edit this profile. Sorry, should have done this beforehand. Cool. Right. Can we see my cursor? So if we do a try, well, let's first do this, right? So if we do 1 divided by 0, that's going to throw an error, right? And you see right here, we're getting a 0 division error. That's an exception, right? And if we do foo, when we haven't defined foo, we get another exception, right? Name error. If we do while, true, print, hello, we get a syntax error. Also can be caught. You can't really do much about a syntax error, but it's an exception and it can be caught. What else? If we define a dictionary equals A1, right? And then we ask for B out of the dictionary, we get another one, right? It's a key error. So there are all sorts of errors that are going on. All of these errors are all exceptions. So if we try, just check out the try syntax. We do 1 divided by 0, except 0 division error, print u divided by 0, right? So instead of getting this traceback that we got up here where it says this traceback, most recent, blah, 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 and then it gives us this error, it's just printing what happened in the except statement, right? If we do a try 1 divided by 0, except name error. You got a name error. Right? If we do something like this, it's not going to catch the exception because we did not specify the correct exception for it to catch. Those need to match. Right? So when I did a name error, we don't see a name error within this like divide by 0 thing. We see a 0 division error. Because 0 division does not match name, then still it never gets caught and it still prints the error in the traceback. You can.
Do you need to have a error name there?
No, you don't, right? I was just getting to that.
Sorry.
No, not a problem. Print, you got an error. Right? So you can do that. You can skip the name, that's going to catch anything, right? You have no idea what it is, but you can catch it and you can do something about it, right? But that doesn't necessarily give you a lot of room to recover from what errors you're getting. If you have a division by 0 error, then you know what's going on, and then you can compensate for that somehow in your code. When you accept an error, like a magical whatever error, then you have no idea what's going on in your code, and there's like not really a good way to recover without knowing what's going on.
Question.
Shoot.
So anytime you try to look up a key that doesn't exist in the dictionary, you get an exception?
Yes.
So is there any way to, so that's the only way to check if something's...
No.
Okay.
Yeah, check this out. Bonus dictionary stuff, a.get b, right? We can do this. We can call a method on the dictionary called get. We hit enter, it returns us nothing, right? Which is awesome, because it didn't error when we asked it for the wrong key. You can even specify a default value right here, and it will return to you the default value if the key is not found. So the get function is what you want if you want to be using dictionaries that have not been initialized. Yeah, generally with the data structures that are within Python, there are like 2 ways to access things. One way that's not going to throw an exception, the other way that is. You know, so pick your poison. What's up?
Is the second argument of that get function, is that definitely default value? Like no matter what you put there, that's what it's going to give you if it doesn't have the...
Oh, no. The default value can be anything, so it can be the number 42, right? And it's going to give you 42.
That's like what that place is for.
Exactly.
Okay.
Yeah. So if we do a help dict.get, well, that's right. So returns to you k if k is in the dictionary. Otherwise, return little d, which is the second parameter, which is the default value that you want to return. That makes sense? Any other random questions about dictionaries or try, except for the moment? No? Cool. Awesome. So, advanced exception handling. Exceptions are all objects, and these objects have like data members. contained within them. So when you catch an exception, you can actually query it for more information about what's going on within your error. So to do that, you store it as a variable using the as keyword, right? So in this example, we have an accept zero division error as e. And e is something, it's an object that we can like print and we can like look at and, you know, try and figure out what's going on. So if we test this, right? If we do a try, well, let's do foo. Accept name error as e, print e, right? So the exceptions are defined to like print whatever error they have as their standard like print function. So whenever you print an exception, it's going to print the error that is contained within that exception. If we try and error equals e, error, nope, that didn't work. Yeah, so the error name that's in it is not just the only thing that's contained within these exceptions. You would have to look up for each one of them, like what their arguments are and like what is contained within each one of these objects, but there is bonus data in them. And it depends on the exception, and it can tell you more and more about the errors that you're getting. For example, a name error, I'm not sure how to do this off the top of my head, a name error is going to tell you the name that erred, I believe. Things like that. So it gives you a better idea of what's going on in your code and a better idea of how to recover from whatever error you're getting. Does that make sense? In theory. Do you guys see why exceptions are like a good idea? Why you want them? Why you want to be aware of like what's going on? Does that make sense? What's up?
How do you know when to use them? Like, how do you know what things are likely to be about to error so that you can figure out how to handle them?
That's a great question. There's really like two ways to go about doing it. I go about doing it the wrong way. I write code, and then I see if something errors. And if it throws an error at some point, then I say, hey, I need to put a try there. That's the way I do it, pretty much empirically. Which can lead to like weird situations where like some super weird corner case that I didn't think of happens, and then I have to like backtrack and like deal with this in like actual code that's being run on a server or something, which is not a great idea. The other way is you can just look it up. Whatever functions you're calling within Python, you can see whether or not it's going to throw an error, because they generally will tell you within their documentation whether or not they throw an error. But that's like a huge hassle.
So then are you preemptively doing this for all of the potential errors that you could have?
You could, in theory, potentially like wrap everything and try and accept. But I just mean like, right, it's totally true. I just mean like if you're calling a function that you don't know what it does, right? Then you would look up like the documentation for that function and see whether or not it throws an exception. And if it does throw an exception, go ahead and put a try except around it, sort of a thing. So it's a couple of extra steps, but it's better practice to do it that way than the way I do it. What's up?
Can you track for multiple errors in the same sort of statement if you know that you might get one, 2, or 3?
Yeah, absolutely.
And then have a catch
Yeah, so if we do 1 divided by 0, except name error, pass, except, whatever, key error, pass, except, 0 division error, pass, right? That's totally fine. That syntax is totally legit, and it will try and figure out which exception is the one that matches one of those clauses, right? So you can chain these as long as you want it to handle like multiple different exceptions. Any more questions regarding exception handling? No? Awesome.
Do you overuse them, or is there any harm in using them?
In Python, no. They've been implemented pretty damn quick in Python. In other languages, they are extremely slow. For example, Java. If you start throwing and catching exceptions in Java, it's going to significantly slow down your code. So the way I've always been taught to program in Java is to try and avoid exceptions in general because they're like poorly implemented within the JVM. But Python does not. Python did it pretty well, so there's not really going to be a performance hit. And you're running Python, So Python's not super fast to begin with, so you can spare the few cycles to throw an exception. Yep. Cool. All right. Cool. So common exceptions within Python include arithmetic errors, lookup errors, attribute errors, IO errors, index, key, and name errors. Arithmetic errors are for when you're doing math wrong. Lookup errors are for things like, I believe they belong to lists. When you try and look up an element that's in a list that doesn't exist, it will give you a lookup error. Attribute errors are for classes. When you try and look at an object's data members and that data member does not exist, it will give you an attribute error. IO errors are for files and things. Index errors, those are for lists. Key errors are for dictionaries, and name errors are for things that haven't been defined yet. All of these and plenty more are documented at Python's website, the docs.python.org, library exceptions. That will tell you all of these standard exceptions that you will see flying out of Python. Right. So you can not only like catch these errors, but you can raise your own errors. So if you have code that you want to fail in a particular way, so if you're writing a library for someone else to use, or if you want to make sure your code crashes if it doesn't have certain files or something like that, you can raise your own exceptions. Yep. Yeah. So the way you do that is you just basically call the raise function, and the raise function, it takes one, well, technically it's not a function, it's a statement. The raise statement takes like one argument, and that argument is an exception, and it will throw that up through your code, right? So we do raise name error, and then this is fun, right? We can do this, and it will just error out the same way it would if we tried to like access some sort of function that didn't exist or some variable that didn't exist. This is throwing the exact same error. Right. Does that make sense to you guys? Yeah? Cool. Do you guys understand why you'd want to throw an error? Yeah? Cool. All right. If you want your code to fail in a way that is predictable, right? So if your code is broken, right, so there are certain cases in which your code won't run. If you don't have proper data files, if you don't have access to a keyboard, if you're like have a video game, you want it to fail in a particular way. You want the user of that program to know what's going on when it fails, as opposed to like this being like this magical failure that you don't know what's going on. That's when you would raise an exception. What's up?
Is there any particular reason why you would use a name error versus any other error if you were trying to raise an error?
Yeah. So you want to pick the error that best suits the situation that you're currently in, right? If it's looking for something that doesn't exist, you would use like a name error or an index error or something like that. But you choose it.
So if I chose the wrong one, would it matter?
No, not at all. It wouldn't matter. It would just confuse the other person who's trying to use your code. That's all. But it does not matter what error you raise. It'll work fine either way. So you can even generate your own ones. If you can't find any that fit your use case, you can go ahead and like generate a pure new one, right? And it's super easy to do so. In fact, the code right there, this class myErrorException, that's it. That's it in its entirety, right? And that will give you a new exception class, which will allow you to raise new fancier errors. So if we go ahead and do this, so we do class myErrorException def init self value equals value def str self return self dot value. Let's wrap this in a string. Why not? Right. So that's it. We've defined a class. It's called myError. It inherits stuff from exception. I mentioned that in passing last class. If we go ahead and do raise myError, this is my new shiny error. Right? You see right down here, it's right there, you know, defined as all the other ones are. It's got a main in front of it because we're running this through our Python interpreter. Generally, that will be your module name. That's going to be prepended to the my error. But yeah, so you can define your own. So if things don't make sense for like the error that you currently have, you can go ahead and define a new one. So it's like fully explicit to the user what's going on. Questions there? No? Awesome. Cool. So now I'm going to blitzkrieg all of you with a bunch of sample code for about 6 different libraries. We're going to do random and math to show some math things. We're going to do sys and os to show some like scripting utilities of Python, how to work with your file system, how to work with files. URLib2 and JSON for like web stuff. CVS and pickle, so you can go ahead and like check out different ways to store data to files, so you can read it in later on. We're going to do date time just for the giggles, it comes in handy on occasion, and PySerial for microcontroller folks. I'm going to like blow through some of these examples. I have sample code for each and every one of them, and then we're going to go ahead and like, after I just show you the slides with like quick example code on them, I'm going to pull up real code that actually uses this stuff. First things first, math. Math is great. It does it has a bunch of mathematical functions within it and mathematical constants. So to get math, all you have to do is import math, and then you can do like math.square root, or math.pi, math.e, math.log10. I think there's a math.log2. So it gives you all sorts of mathematical functions. I'm going to break what I just said and just show you that we can do an import math. And if we want to see what's contained within this package without hitting the web, we can always do a help call. Yeah, I was going to type math, it happened. So if you check out the help on math, it's going to tell you all of the functions that exist within it, what their arguments are, how to call them. And if we scroll down further, there should be a section with all of the mathematical constants.
And is math,
there we go. It's only 2 of them.
Always in there? So, I mean, or is math a Python library as opposed to one that I have to get from somewhere else?
Yep. Yes, math is going to be bundled. So all of these libraries that we're going to cover really quick are going to be bundled with Python except for Pygame and PySerial. Those are the only 2 that we're covering here that will not be.
And those 2 require some extra magic incantations because they are not part of.
Pygame does. PySerial, not really.
Okay.
Pygame is just like way more complicated than PySerial. So that's really it. All right, random it was in the Pong code from last week. It adds uncertainty to, you know, all sorts of code. It's fun for video games because you can make random things happen to make your video game actually, you know, fun. You can add a seed for reproducibility. So if you use the same seed, it's going to give you the same series of random numbers, which is cool. So if you give it a seed that you remember, you can have it actually like repeat the same random number sequence over and over, like in a specific way, so it doesn't like mess you up. Rand_int takes two values, 10 and 20, and it's going to go ahead and give you a integer with between the range of 10 and 20 at random. Random choice. This is really fun. I've picked where to go to dinner with this a bunch because I'm a nerd. Random.choice, you pass it a list, and it will go ahead and give you a random selection out of that list. It'll go ahead and pick one element out of that list and tell you where you're going for dinner. You can even do cool things like Gaussian distributions and like grab a number from a Gaussian distribution and things like that. Date time. Date time formats dates and allows you to do queued operations on them. My birthday is right there in a date form. You can get like different formats out of it. So ISO format is going to print it out in a very specific string. You can figure out what weekday my birthday was on using like the weekday function contained within the date object. There's a whole bunch of things you can do. You can add time together. So you can do like now plus 20 minutes sort of a thing. And all of that's already built into Python. Cool. Sys allows you to access your system, basically. The most common use you'll see of sys is for the arguments, your command line arguments. So if you're calling a Python script from the command line, sys.argv is going to contain all of those command line arguments. You can exit with errors using sys.exit. You can figure out the path of your Python to figure out whether or not modules are installed or things like that. If you do sys.path, it's going to show you the list of file paths it's going to search for all of your functions, your modules, your packages, things like that within Python. And you can even add new things to the path just by doing a path.append. All right. OS allows access to command line tools. So you can like list a directory, you can split paths. Splitting paths will give you the path and the file in a tuple. Split extension is going to give you the file name and the dot extension part in a tuple as well. And you can do arbitrary system calls doing os.system. You can just like make like a bash call and it will execute it for you. What's up? What's a path? Yeah. A path is like the folders you go through in order to get to a specific file. The series of folders you go through is called a path. So you're basically like wandering through your file system in order to get to a specific location. Those are generally separated by slashes. Windows users, you're going to see the wrong way slashes. But yeah, that's all it is. It's like a location in your directory.
So what does it mean to split one?
To split one? So if we do this, right? We do an import os.path.split / accept var log messages.log, for example. It gives me the base file name on the right hand side of that tuple, and then it gives me the folders it had to go through in order to get to that file. Right, so sometimes you only want the base name of a file when you're processing things. Other times you want the path that took you to said file. So this is just like a cute way of like snipping them apart. This will handle things like different operating systems too. So if you're running Windows versus Linux versus Mac, Linux and Mac use // Windows uses backslashes to separate folders. So this will handle that for you. You don't have to think about it. It'll just do it automatically.
So this tells you what's the path, what's the file.
Exactly. Cool. Everyone good there? Like I said, tons of example code. It's going to be fun. URLlib2 is pretty awesome. It opens URLs, and you can like pull data off of websites using this one, which is really fun. So you can write like website scrapers and things like that if you need to get information off of like, I don't know, Flickr or something like that without logging in and using their crazy API. You can just like write some sort of crazy scraper in order to do that. They frown upon that though. You should probably use their API. So yeah, you can do a URL open, pass it a URL, then that returns to you some object which has a read function on it. When you call the read function, it's going to give you an HTML dump of that page, which is pretty cool. And then you can actually like parse that HTML dump using other tools that are found within Python or third-party libraries. The most popular one for manipulating HTML like that is Beautiful Soup, if I remember correctly. That handles really ugly HTML, so if someone like wrote poor HTML on their web pages and you download it, Beautiful Soup is a great way to deal with that, regardless of whether or not it's full of errors. Yeah, which is neat. This little example snippet shows like writing the page contents to a file as well, just because why wouldn't you want to do that? You have this shiny new HTML page, why not write it to a file? Yeah. JSON. How many of you guys have heard about JSON? Most of you guys? Yeah? A few of you guys? What's up? I take that as a no. All right. JSON is a way of structuring your data that it just makes your data look like a bunch of key value pairs contained within JavaScript objects. Right, so you have like curly braces and single quotes and then a key and then colon and then your value, comma, and then whatever. So this is just a way to parse that information like automatically. So you can like hand it strings or you can like hand it you hand it a string that contains like JSON in it, which is basically like JavaScript object stuff, and it will spit out to you in a Python dictionary form the stuff that was contained within that string. It'll also print things very pretty for you, which is awesome. If you do like a JSON dump sort keys true indent 2, it's going to tab indent everything properly, and it's going to make sure that all the keys are sorted in alphabetical order, which is super nice. Yeah, but this is cool. What's up?
But you couldn't sort keys.
This is different. So if you're using that's totally true. If you're using like an actual Python dictionary, you can't sort keys. What we're talking about right now is like this JSON structure. So basically it consumes all of the data within this JSON.dumps function, figures out all of the keys, it kind of like stores them in its own personal memory, then sorts them, then prints them, sort of a thing. So you're right, you can't sort keys, but this does some magic behind the scenes in order for it to like write a string that has the keys sorted. Does that help or hurt?
That's fine.
All right.
What if indent is this as well?
Indent?
Yeah. It's just all we're discussing is line.
All right, import JSON. JSON.dumps. What was it? X120, Y340. X120, Y340. We do something like that, right? It gives us a single line with everything on the single line. And we do something like, let's reverse these just for the giggles. And we see it prints them in order. So it just iterates over the keys in its order. If we do a indent equals 2, it puts new line characters where things should be, right? So it actually like breaks the lines and puts spaces in so things are tabbed in nicely. So when you read it, it's actually like human readable. Instead of like one single huge line of text, it's going to be like broken up in a way that you can easily read it. That's all it's meant to do. Indent specifies the number of spaces per like indent, right? So in this case, it's going to be 2 spaces, but you can make it 8 or 16 or whatever you want.
If I made it 0, would it just list them all out over each other without doing that?
Huh. Yes, that's exactly what it would do.
What kind of data can you store in a JSON format file? Is it just like variables and single values, or can you store lists of things?
You can store lists of things. You can store strings. You can store values. You can store key value pairs. You can nest key value pairs, so you can have like, it's just like a dictionary in Python basically. The only thing you're not going to be able to do really well is objects. Right? I'm going to show you another way that you can actually store Python objects persistent to disk, which is totally rad. So you can like bring them up again, you know, like things that you've already been using that have some state. Maybe you've like read a bunch of information into it and started processing it, pull it off of disk and just start going again after the machine starts again. Yeah, the only thing you can't really do with JSON well is Python objects, but you can store key value pairs, arrays, numbers, strings, whatever. Does that answer your question? Cool. All right, CSV is another way of storing information. This one's nice and easy. Comma separated values, right? This is just a cute way to read and write comma separated value files. There are different like dialects within them. So like Excel has a very specific way it likes to output CSV files when you hit export to CSV. This CSV library handles that, so you don't need to think about it. It'll just do it. You can basically open CSV files, read from them. You need to create a reader or a writer depending on what you're doing, and then you iterate over that reader, and you know, it's no big deal. I have sample code that's going to show how this works as well.
It's CSV.cds.
Yeah, nice call, thanks. I will change that.
Convenience value service.
Yes. No, not that. Cool. Pickle is another way of storing things to disk. Do you have a question? You just scratching? Cool. Pickle is another way of storing data to disk. This is cool because it specifically stores Python data structures onto disk. So if you want to save, you know, the position of your player paddle in Pong for whatever reason, you can save that in a pickle file by doing like, you would open a file and then you would pickle dump whatever object it is into that file. You can also load it right back. Those are two ways. You would go ahead and like write the player and then like read the player back in from file. PySerial, this is not included with Python. This is a third-party library. You need to go and find it. It's awesome. It writes to serial ports, which is totally great when you want to do microcontroller stuff. All you have to do is create like a serial object. Within that serial object, you specify the device you want it to be reading off of and the baud, and you can write characters to it. You flush the serial port. You can read bytes from it. You can specify how many bytes to read from it at a time, and then you can go ahead and close it when you're done with it. Simple as that. It's really neat, really convenient for when you want to like debug Arduino stuff, but you don't want to use Arduino's IDE for whatever reason. Like this is totally rad. That's awesome. Any questions there?
Parallel? You see parallel ports?
I don't think so. Yeah, I don't know. I haven't looked into it. I don't have any computers that have parallel ports. Cool. That's really it. So we're going to go over code examples in a second. Do you guys have any questions about Python at all?
Why is Python so popular? Why is it?
It's
Everyone I spoke to, they're like, oh, Python, or can't Python.
all right. Well, I'm going to answer your question first. Python is popular nowadays because it's relatively fast. It moves, at the speed you want it to. It's got a ton of libraries packaged with it, so you can do all sorts of crazy shit out of the box. It's got a great community that's like actively developing the language, actively developing new modules. It's relatively friendly towards beginners. It's got a decent syntax and nice language features. So it's like a good language all around. The reason it's polarizing is because I bet the other people you talk to are Ruby programmers, and
Yes.
yeah, there's just like this random battle between Ruby and Python for whatever reason. I mean, they both have their strong suits and they're both great languages, but people prefer one over the other. I'm in the Python camp. Whatever, it's a thing. It's a religious war.
When I first started trying to learn about Python, it was Python versus Perl. And there were way more Perl people than Python people, because Python was just saying, and I think Python won, basically, because I don't see a lot of stuff being done in Perl anymore.
Right.
Stuff.
Right. I had no idea there was the same war. That's awesome. That's way interesting.
Because the philosophies are like opposite philosophies.
That's totally true. Yeah, hack it together versus make it clean. Yeah.
Yeah, Ruby is more of like a linguistically purist language, and Python is more of a pragmatic language.
I would argue that, but I'm on film. Yeah. Any other questions about Python as a whole, in general? Community, libraries, random syntax we went over, objects, classes, whatever.
If you find something like PySerial
Yeah.
out there somewhere, how do you install it in your Python installation on your...
Man, that's a decent question. This is one of the shortcomings of Python. I'm going to go ahead and say that. So like in a language like Ruby or Perl even, you have this really cool like package distribution system where you can just go ahead and do like a gem install and get something, or a cpan install and get something. Python has pip or easy install. Pip is the new popular one, right? People are using pip now?
I think there's the new one, but it's not easy install.
Alright, well, for whatever reason I've heard that people are supposed to use pip and not easy install. But if you go ahead and you find that installer, basically it's going to help you install third-party libraries right off the bat. But pip or easy install, they both work fine. Sometimes they mess up and it's kind of a hassle to deal with, but generally they do their job really well.
So do you have to install that before you...
Yes. Yeah, but it comes in like, what are you running, Windows? It'll just come in an executable, or if you're on like a Linux machine, you can just install it via your command line as you would anything else. So the install for pip is going to be super easy, and then you can just, from your command line, or whatever interfaces are exposed to you via Windows, you can go ahead and ask for new packages. Any other questions? No? Cool. Well, homework. I'm still going to give you homework. And you guys should know that HacDC is going to be open for Software Thursdays for like evermore. So if you guys have any questions with your software stuff, come in and we can chat about it and figure it out. I'm providing data files for, last time I taught this class, it was right after the tsunami in Japan. So we found a bunch of CSV files that contained radiation data from the reactor leaks in Japan, which is like pretty interesting information. So challenge is to like go ahead and try and visualize radiation data, or we had some URL data from a hackathon for Bitly that was going on at the time. You know, we have like a couple of like a JSON file and a CVS or a CSV file that you can play with. Try and pick one of the libraries, poke at it, see if you can't make it do something fun. And that's about it. Yeah? Code examples? Sweet. All right. Sweet. All right. So we have a CSV example, which I spelled wrong there too. Nice. A JSON example, a pickle example, spelled that wrong too. PySerial, and a URL-lib2. So I'm just going to go ahead and start at the top. I actually thought I had a few more example pieces of code, but this is fine. Check this out, short and sweet. This is showing you how to read from a CSV file and go ahead and append something to the end of that file once you have read from it. So we talked about the with statement before in class. The with statement allows you to open files and not worry about closing them again. It has some sort of like context within it that figures out whether or not you're done with this object and deals with it. So basically the first thing that we're doing here is we're opening the CSV file as read and calling it f, right? You see that as again, just like in the except thing? Well, this as is saying that we're going to open this test.csv file as a read-only file, and we're going to make it called f. We're then going to create a CSV reader from that file, which is going to allow us to read all of the lines.
Is f the name of the file?
F is the name of the file object.
Okay, so,
So there's two things going on. Bingo. Yeah, you got it. You got it. Does everyone else understand that? That was a good question.
Can you say, so the R is the file and the F is the object that it gets called up?
So the test.csv is the file that's on your hard drive.
Okay.
The R tells you what mode you're in when you're going to be looking at it, right? In this case, we're going to be reading to it. In the second with statement, you can see there's an A, that's for append. The as F is how we're going to refer to that file within our Python program, right? So we're never going to do anything with test.csv ever again. We're just going to use the F in order to deal with it. That make sense?
Yeah.
Awesome. Right, so first line within this with statement, right here, we got this test reader equals csv.readerf. So the csv.reader creates an object, a CSV reader, from a given file. And what that does is it basically will eat every one of the lines in the file and return to you like a list of the elements that are contained within that file. So it's going to split on commas for you automatically and just return to you a list of the comma separated things contained within a list already for you. So you don't need to think about breaking it up yourself. It's just going to give you the individual elements. I will add that all of the elements are going to be strings, right? So if you have a bunch of numerical columns, you need to convert those yourself. This is only used for splitting on commas, for like breaking those lines up on the commas. Does that make sense? Sorta? Alright. Cool. So once we have our reader, we can go ahead and use it as if we were using a file. So for row and test reader, print row, right? That's the same way we would print all the lines for a file, except we would do it like for line in F, or print line, right? So it's a very similar construct you would use to a file. It works just fine. If we look at the case where we're adding something to the end of this file, we go ahead and open it, the file the same way, except we change the mode that we open it in. we create a writer by passing csv.writer, the file that we want to act upon, and then we just do testwriter.writeRow, and we give it a list of things, and it automatically writes that as like proper comma separated value stuff to the end of the file we just passed it. Right? So let's go ahead and run this. Python CVS. Right, cool. So we can see here, not very exciting, but it prints a row of everything. In this case, there's a header, there's me, there's a few different people, right? And it's just printing everything. So we see right here that when it does find a numerical column, it doesn't convert that automatically for you. It leaves it as a string, as I mentioned before. So you got to change that yourself. So in our code, we would in your comma separated value file, right? So ours looks like this, right? And we see right here there's a 23, a 25, a 29, a 34, right? All that stuff going on there. That's just a column that contains numbers. That's all I meant by that.
But what should it be doing with those that it's not doing?
Making them numbers, right? Wouldn't it be really convenient if it could detect whether or not those were numbers and then just automatically convert them for you? It doesn't do that though.
Because it's got those quotation marks, right?
Yeah, exactly. So if we look here back on the command line, we can see that 23 is surrounded in single quotes, which means it's a string and not a number. But it would be really nice if it converted it for us, but it's really hard to tell whether or not you want to do that.
So if you did, let's say, I referred to that in the array, and I did times 4, it would do 23, 23, 23, 23.
Yes.
Because it thinks it's just like a series of words, not a...
Bingo. So if we wanted to, CVS, right. If we wanted to go ahead and print this properly, we could do for name, age, color in test reader, print name, int, age, color. We can do something like this, right, which will get rid of this issue and make things print nicer. So if we, oh, I see what happened there. So this is the case, right? Like right now, so I ran this code and it gave me this value error, invalid literal int for base 10 age, right? So it's giving me this error. This is the perfect time to use the try and accept thing, right? So I ran it, I see there's an error, that's awesome. Why is there an error? Let's check out the CSV file at the top. There's a header row, right? So the first time we're gonna run this, there's going to be an age instead of an actual number there. So we can go ahead and ignore that safely. So if we do, if we go ahead and do a try here, accept because I'm lazy, pass, right? I didn't mean to quit. You all see what I did there? I wrapped that print statement in a try just because it erred. I threw an accept there to say if an error arises, don't worry about it. It's cool. Just continue doing what you're doing. And then, you know, it should work fine now. So if we go ahead and run this again, we see right here that it prints name, which is fun, because it gets to the part where it prints the name and then it breaks on the rest of them. So it prints that first part, which is not what I expected. And then it goes on to the rest of the lines. But if you look here, this 23 is no longer surrounded by quotes, so we got rid of that issue. So this is actually can be treated like a number in our Python code. Yeah.
So then can we go back to the code for a second?
Sure.
So another way to handle that might be to just do print name age without the int thing and color.
This is true. If we did this,
No. If we're under the accept.
all right, under the accept, what am I doing?
Do
Print
name twice.
name.
Oh, you're right. So actually,
Yeah, the correct thing to do would be instead of using int, you would create a function that has the try accept in it and use that function instead of int.
Right.
Explicit cast.
Yeah, I mean, there are many ways to go around like this issue, but, you know. whichever works. Do you guys want to look at this code more? Can I move on to the next piece? Yeah? Cool. Let's look at the JSON example next. Do we have a JSON file? Weird. Oh, that's fun. Oh, right. So last time I was teaching this class, there was a USA.gov hackathon that was going on, and they were giving out all sorts of crazy bit.ly data. So I don't know if this code's going to work again. But the code looked like this, right? So it was a set of key value pairs. Well, the JSON looked like this. It was a set of key value pairs where like A was user agent, C was the country code, NK was whether or not this was a known user, G was the global bit.ly hash. So it gives you all this crazy information about this stuff, including like the GeoCity name and the latitude and longitude of this person's location when they created the link on bit.ly. It's like awesome. So much fun to play with, right? Because you got all this information, you can do really fun things with it. So this code here does a lot of fun stuff. It goes and it opens a URL and it starts reading in rows from that URL. It starts reading in data from that URL. And it parses it using the JSON library, and then it prints a bunch of the latitude and longitude locations. So I want to see if this runs. Python JSON example. Error 404 not found. Right. Cool. So what this is telling us is that website no longer exists. So the data that we were using for our JSON objects is not going to work anymore. But you can still look here for like, this is a way you would download information off of a web page. So right, this is a URL open. We pass it a URL. The URL we define at the top of the file right here, where it's just some like random URL that USA.gov gave us to play with. We create this data list, and we go ahead and like parse each one of the JSON. So every row in that HTML file was another row of JSON. So we would read this file in row by row, break it using, we would strip the white space off of the ends of it using like the strip function. We would go ahead, skip it if it was blank. We would try and load it as a JSON object. And if it worked, we would print the location and save it to like this data list. So we could like continue to have all of these dictionaries, these Python dictionaries now. So we take them off the web. When they're JSON, we convert them from JSON to Python dictionaries, and then we store them so we can actually use them later on in this code. Sorry it doesn't work. I will try and figure out a way to either get that info or different feeds of JSON info. Any questions on this code? The URL lib2 stuff I'm going to cover a bit more in a second, just for funsies. But is this relatively self-explanatory? This JSON.loads function does all the heavy lifting. That's what takes a string and converts it into a dictionary, as long as it's properly formatted as a JSON object. If it's not, it throws a JSON exception. What's up?
So is this looking for data, or is it looking for like commands and stuff?
It's looking for data. I mean, a lot of people on the web are starting to use JSON to send commands to things, right? So like you'll post something to a web page, and with that post body you'll give it a JSON object, and that JSON object will tell the web page how to react based on that. So you can like create all those same functionalities within, like all you need is a JSON object, right? So it doesn't matter as long as it's formatted properly, and you can like spit it off that way. Does that help or hurt? Good. Cool. Alright, the next example is going to work. Cool. Awesome. So in this file, we've got a class defined as a player object for an RPG. Right? So this player has hit points, and they have mana points, and they have a location. They have a couple of functions applied to them, so they can take damage, they can use mana, they can change their location. And we have this little string function that just prints the some sort of representation of the player. Repr does the same thing. In our main function here, we create a new player, we print the player, we make the player take some damage, use some mana, and then change its location to Mordor, because clearly that's important. We print the player again just so we can see what happened to the internal state of that player. We go ahead and open a new file, and we dump that player into it. And we set that player to nothing, right? So we kill that player effectively. Then we go ahead and print the player. It's probably going to give us an error or nothing. And then we go ahead and open that saved player file, and we read it back in, and we print the player, and it's totally back in order. Right? It's all like magic. Python pick. Cool, right? So you can see right here, this is when the player is initialized, right? They have 100 HP and 100 MP, and they take some damage and use some mana, change their location to Mordor, and we delete them. And when we print it, we get that. And then when we read back from the file, we get exactly what we wanted back. Just for giggles, let's take a look at the saved player pickle file. So we look at it, it looks like gibberish, right? None of this looks like anything. But all of this crap that's in that file makes up that player. That is player 1, whatever that is. Yeah, all of this happens behind the scenes. They have some sort of crazy scheme of reading all that crap and then making sense of it. But I haven't read into how that works, so I don't really know. But it's fun, so you can actually look at your data, and I see hit points and location and Mordor and mana points, but I don't really know what most of this means. Well, I see an I-56, that probably means there's 56 mana points or something, and an I-80, which probably means hit points 80. But yeah, that's super fun.
Do you have binary information to convert it into a text format somehow, or does it store the raw binary stuff?
I do not know. I believe there's a way to do binary pickling. I'm not positive on that. I think there's a way you can specify whether or not to use binary or ASCII. But in terms of just using the standard pickle and storing binary data, I have no idea how it works. I've never tried. But generally when you're storing binary data in Python, you save it in strings. You do bit string manipulations, which is kind of sloppy, but it turns out XOR is ridiculously slow in Python. So you don't really do bitwise operations, you have something else do bitwise operations for you. Any questions on pickle example? See how cool it is? You can save your progress for whatever you're processing or whatever video games you have going on. So you can have a save game thing now, which is awesome. No? No questions there? Sweet. Let's go over the PySerial example just for giggles. Oh, that's fun. This uses Pygame as well. So this PySerial example, cool.
This actually could be fun for robotics.
Oh yeah, it could. Yeah. So this PySerial example was meant to go with, we had another class here at HacDC. I've got to update some of these examples. We had another class at HacDC at the same time I was teaching this the first time for microcontrollers. And we were using Elliott Williams' classboard in order to go ahead and play with it a bit to show some neat things. So basically what this did is if you hit space, if you held down space, it would turn the light on, and if you released space, it would turn the light off. And that's all this code would do, right? So the way it would do that is it would go ahead and initialize Pygame. We were using Pygame only for events, so we were only using it to capture our keyboard events. We created a serial device called Sir by doing serial.S serial. We were giving it the device name, in this case dev TTYACM0, and the baud rate 9600. We created our screen and our display caption as the way we always did for Pygame. And then we had our event loop where we would go over each one of the events to check to see whether or not they were a key down on space or a key up on space, right? And if it was a key down event and it was a space, we would write A to the serial line. the microcontroller would then digest the A, and it would do something, right? In this case, light up. And when we released the spacebar, it would go ahead and write B to the serial line, and then it would turn the light off. That's all it would do. So it was just kind of like some silly light switch where we hit spacebar. But it was pretty cool. This is like a neat way of, you know, doing some event handling within your system. There are cleaner ways to do it now, but this is just the quickest way we could come up with, just for a quick, easy demo. Yeah. One more example. That's a quick example. Awesome. So what this does is this is just another example of how to use URL-lib2 to open URLs and read the information off of the web. So in this example, we are reading all of the information off of the HacDC.org website, the wiki, for the Intro to Programming class, this class. So basically, we just open the URL, doing URL-lib2.URL-open, and passing it the URL of the website we want to grab. We go ahead and read the data from the page file using the read function. We store that in a variable called data. We open a new output file called programmingpage.html, and we open that in write mode. We go ahead and do output file.write, and we write all of the HTML data that we downloaded off of the internet onto our new file, and we go ahead and close the file. And that's all there is to it. So if we run this one, Python URL-lib2, it's going to take a bit. And if we look here, programming page.html. This is the HTML of the wiki page that contains all of the stuff for this class. Right? So no big deals, but once you have this, you can do all sorts of fun things with it. You can like strip out certain bits of information that you want or that you don't want, and you can like find patterns in data and visualize things in cool ways. The sky's your limit. Web is really fun to play with. It looks like it looks like those were all the code examples I had for tonight, which concludes the Intro to Programming with Python class. Do you guys have any extra bonus questions now that we've covered some sample code, things like that? No? Awesome. Well, thanks for stopping by and taking my class. Hope you enjoyed it. Yeah, my pleasure.